So, welcome to lesson 3 of your ecology unit of work, which is on adaptations. Get ourselves ready. So, obviously, starting as we do with every lesson, have a look at page 23, where it says adaptations at the top, gives you a little bit of specification detail about what you need to be learning about adaptations. And then there are some knowledge recall questions based on what you've looked at in ecology so far. So, pause the video and then give yourself a little bit of time to have a go at the knowledge recall questions on the next page or so, based on this unit and a couple of questions from previous units to jog your memory and test how much you can recall. Once you've done that, we will start the video again and go through the answers. Right, now you should have unpaused the video. So if we have a look at our answers to begin with. Describe how predators feed. Nice and simply, predators feed on prey. Define extinction. Extinction is the total loss of a species. Define a species. A species are organisms who are biologically similar, who can breed, and they can produce fertile offspring. So offspring that themselves can reproduce. Define the term biotic. So biotic are living factors that affect communities within ecosystems. Give 2 examples of biotic factors, a couple we've quoted from last lesson, predators and pathogens. Explain why there is a delay in predator response to prey, because the corresponding population needs time to reproduce or consequently to die if their numbers are going down. Define abiotic. Abiotic is a non-living factor. Give 2 examples of abiotic factors. Carbon dioxide levels is one for plants, and also water. Both of those are needed for photosynthesis. Then from previous work on genetics, what's a phenotype? Have a quick drink that. A phenotype is a physical expression of genetic characteristics. It's a physical expression of genetic characteristics. Right. We get rid of that page. And then come down to the last question at the top. Define activation energy. So activation energy, when we're talking about chemical reactions, if you recall, is the amount of energy that you need for successful collisions and therefore reaction to take place between different molecules or atoms. So this lesson is going to give you an overview of identifying adaptations in different organisms and explaining why organisms develop adaptations. So what are adaptations? Right. First thing to bear in mind here is we can bring a little bit of history of biology. Now, there was biologist, the second name we had called Schmidt-Nielsen, who in around 1960 wrote a seminal paper called Animal Physiology. Now, he identified and sort of came up with a term that's pretty relatable and good to understand when we talk about adaptations, is the ecophysiology of an organism. Now, the ecophysiology of an organism is worth noting down, it's described as how the anatomy of organisms is linked to survival, distribution. Right on the right page here. Distribution, abundance, and fertility of a species, which is basically what we're talking about when we're talking about adaptations. So as the paragraph says, different organisms can survive in different environments because they have adapted to suit them and can compete more successfully for resources within them. And when we're talking about competing more successfully, they can outcompete other organisms, other animals, either within their species or different species. Now, these adaptations give what we might describe as an evolutionary advantage. So these adaptations have developed over time due to the evolution of the organism, and that has given them an advantage to be able to survive. And it's through a process called natural selection that you'll come on to talking about a bit later. All organisms, including microorganisms, gradually change over time to suit the conditions in their habitats. These features or characteristics they adopt are called adaptations. There are a wide variety of different types of adaptations that can be classified by type: structural, behavioural, and functional, which we have touched on before, but we're going to touch on again. So, if we talk just briefly, all organisms, including microorganisms, gradually change over time to suit the conditions in their habitat. These features or characteristics they adopt are called adaptations. So these features, because they're more suited to their environment, they are more likely to be passed on to the next generation. That's the basis of evolution there. Natural selection. Now, if we think about these three types, structural, behavioural, and functional adaptations, it's worth just turning to your notes page. And in terms of the pages you've got, last page of this lesson, I think it might be listed as around page 30, just the lesson 3 notes page. And have a think about the 3 definitions that we spoke about last lesson. You might want to note this down as well. If we think about polar bears and camels. Now, to begin with, structural. So if you remember, structural adaptations are physical features. So, specific skin type, claws, teeth, fur colour, etc. Behavioural adaptations are just behaviours. They're adapted, changed. And functional are processes that the organism carries out, biological processes that are changed in order to be able to survive. So you might want to note these 3 down, just to remind yourself about last lesson. And if you think back to when we looked at this before, structural, physical features. So the physical features of a polar bear: sharp teeth, claws, they've got forward-facing eyes. This is all for predation. Speed and strength, so they can run and catch things really quickly. Camouflage, obviously white snow, white fur, great. Small surface area to volume ratio, and lots of fat and blubber to keep them insulated in a cold environment. Behavioural adaptations, they've adapted so that they hunt in packs, so they're more likely to get food and share it. Huddle together when it's cold. Functional, So one of the processes they might undergo is hibernation. So physically hiding, sleeping for a prolonged period of time, slowing down the metabolism within their body, the chemical reactions that are going on in order to be able to conserve resources and survive. That's changed to a biological process. Whereas if you think about camels, they've got eyes on the side of the head, look around, can see whether they're going to be predated on more easily and sort of attacked by other animals. Camouflage, again, fur colour, skin colour, similar to the environment. Quick and agile, they can run pretty quickly to try and get away from predators. Large surface area to volume ratio means they release heat really easily, so they don't get overheated in desert environments. Splayed hooves increases the surface area on which they're standing, so they can stand on sand more easily. Long eyelashes, so they don't get sand from sandstorms in their eyes. They migrate, so that's a behavioural feature. They obviously move and go and decide to live somewhere else based on the conditions that they're currently in. And then a biological process that they change in order to help survive and adapt is they produce less urine, so that they waste less water. So it might be worth just noting down those features just on your notes page, just to remind yourself about structural, behavioural and functional adaptations. If needs be, pause your video, and then once you've unpaused it, come back to where we left off in the lesson. Right, should have unpaused the video. So if we carry on, having looked at our 3 adaptations of structural, behavioural, functional, remembering these are changed processes and these are changed physical features. Now, let's go through some of these adaptations just underneath in a little bit more depth as well. So, structural adaptations. These adaptations are features of an organism's body structure, such as size, shape, or colour. So these are, as we've said, physical features. For example, the Arctic fox has white fur in winter to camouflage it in the snow. This adaptation helps them to survive by avoiding predators and hunting prey without being seen. Other examples are thick layers of fat to keep warm and cold. Watch the typo there. Places, hard shells to protect vital organs, large feet to prevent sinking with in soft ground. Plants also have adaptations. For example, cacti. Touched on those thinking lesson 1. The cacti that live in hot, dry conditions have thick stems and spines for leaves to protect them from being eaten and preserving water. So, because it decreases their surface area to volume ratio. Now, as we've touched on, other examples. We hopefully should be able to list off a few of these. Other examples include sharp teeth. So, surface area to volume ratio, large or small, depending on whether it wants to retain heat or lose heat. Reproductive timings. So production of hormones and things like that in a monthly cycle in order to be able to reproduce. If you think, for example, about the menstrual cycle, that's an adaptation. Functional adaptations. Functional adaptations describe the processes within organisms that have altered to assist survival. Processes such as metabolism, reproduction. For example, lots of organisms hibernate, as we've said, e.g. polar bear. Overwinter to avoid cold climate. Their metabolism reduces to conserve energy when food is in short supply. So remember, metabolism is the sum of bodily chemical reactions. So you reduce metabolism, you're reducing the chemical reactions in your body that require energy. So you need less energy. Other organisms that live in hot climates produce very little sweat and very little highly concentrated urine in order to produce water loss. So we've said, e.g. camel. When we're talking about processes, other processes we can be thinking about are things like photosynthesis, and poisons and venoms that animals and plants might produce for protection. And then finally, just recapping these behavioural adaptations, the way an organism behaves can help it survive. So it gives it an advantage. That's what we mean here. Being aggressive is seen in pack animals, migrating, as lots of birds do, and mating dances, such as the male peacock, are all examples of specific adaptations in behaviour. So we might also think about things like, e.g., making nests. And when we're talking about mating dances, that's for courtship and reproduction. So rather than fighting, for example, as more aggressive animals might do in packs, you might have birds and things like that who do specific dances that are designed to attract the opposite sex, and the bird who is the most proficient mover and shaker and can do those courtship dances the best will be the one that will attract the best mate or the most mates. So it's just a different way of competing. Right. Draw a table to summarise and show the key differences between structural, behavioural and functional adaptations in animals. So if you want to next, pause the video and just in your own notes, have a go at doing this yourself. Watch the below video first, and when you've got a bit of space, you want a definition for each and examples of each in a table. And I think you're probably proficient enough to be able to do that yourselves using the notes that you've gone through over the last couple of lessons. Okay, so that's your next learning task, just to do that by yourself in your own notes or on your own notebook, something like that. Pause the video, do it, and then once you've done that, you can unpause the video and we will carry on. Right, hopefully you've done our last learning activity and you now unpause the video. So if we now move on to the next page, where you will see a couple of questions. Now, let's see if we can just think about how we apply this one ourselves, having spoken about these ideas a little bit more in depth, and interpret this question. So Arctic seals are a species of seal that are adapted to live in cold regions of the world. Suggest and explain 2 ways in which Arctic seals may differ from common seals. So Arctic seals is all about the cold. So 2 ways. 2 adaptations that allow it to live in the cold. So that's what is meant by the term suggest. So you list 2 adaptations that an Arctic seal might have that a common seal doesn't have. To get you 2 marks. Now, where are you going to get the 2 marks? The other 2 marks are in the explain. So this is the why. Why do those 2 features that you've identified allow them to live more easily in the cold? So that's what this question is asking. So if you think about an Arctic seal, one feature it might need to live in the cold is to have more blubber, which is fat under the skin, or even more simplistically, fur. That's one feature, one adaptation we've just identified. If it's Arctic, it's in the snow, and it doesn't want to get eaten by polar bears, it might have white fur. So if we'd written these 2 things in our question, we'd get 2 marks. That's it. So now we need the 2 marks from the why. So why is more fat, more fur important? It's more insulation. That would be the key word. More insulation from the cold weather and the cold water. Whereas white fur, camouflage from predators. Camouflage from predators. So that's how you'd go through this one yourself. Right. Again, I'm going to give you a little bit of time to work on something independently. If you have a look underneath, you'll see there are some more examples of adaptations. Courtship and hibernation behavior. So we're thinking about behavioral adaptations, and we're thinking about functional adaptations. So I'd like you independently now, and I don't think you need me to review this with you at the end, watch the 2 YouTube clips that are listed on your page. Underneath, describe the adaptation you observe. So what's the animal? What is the adaptation? Categorize the type of adaptation. We've just done that, behavioural and functional. And explain how the behaviour increases the chance of reproduction. So courtship dances, how does that increase the chance of the organism being able to reproduce more? Hibernation, how does that increase the chance of the organism being able to reproduce more? So have a go at those 2 activities. Pause the video, look on your pages, find the YouTube links, and then once you've done that, we'll go into our next section. So pause the video now, have a go at that. Right, now you should pause the video. So once you've done that, we can move into some of our later sections of this lesson. So underneath, where we're looking at living in extreme conditions. So let's break down this text together. Some environmental conditions around the world are so extreme that the existence of life should be impossible. However, some organisms manage to survive. Some examples include deep under the sea, where the pressure is very high. You've also got to think deep under the sea as well. Oxygen level is going to be very low. Volcanoes where chemical concentrations, and temperatures are very high. So, might be, for example, very acidic conditions. Or in the Dead Sea where salt concentrations are high enough for a person to float without effort. Now, salt concentrations, why might they be extreme? Because salt concentrations affect the ability of water to move in and out of organisms. Right. Despite such hostile conditions, some organisms have developed adaptations that allow them to survive. These organisms are called extremophiles. So that's your key word here. Extremophiles are organisms that live in extreme habitats. Extreme habitat conditions. So, some microorganisms are extremophiles. For example, the bacteria Thermococcus littoralis has adapted to survive and reproduce in temperatures between 85 to 88 degrees, a temperature too hot for most organisms, as their proteins and enzymes would become denatured. If you remember the term denatured, it means they change shape. And what do enzymes do? They catalyze reactions. However, not all extremophiles are microscopic. Plants and animals have shown extreme adaptations to live in extreme environments too. Now, if we have a look at the little exercise underneath, hydrothermal vents are found on the seabed. The water that leaves these vents is very hot because it's coming from volcanic rocks. Bacteria and other organisms that live in these environments are called thermophiles, which means they love heat. Alongside these bacteria are a plethora of other organisms in close proximity, so they're nearby. Now, give the term used to describe the bacteria that live in hostile conditions. We've said that they are called extremophiles. Explain why other organisms are found nearby. Why would other organisms live nearby these bacteria? It's so that they can prey on the bacteria. Now, suggest why organisms live near the vent, even though the bottom of the sea usually has no light, high pressure and low temperatures. Now, the bacteria live near the vent or in the vent as it is harder to be preyed on. So therefore they want to be able to survive more. So they've adapted to try and live within that environment. Good, well done. Now, once you have done that, there is a last couple of activities for this lesson that I'd like you to have a look at. So, if you turn over, you'll now see a picture of a camel. Camel is well adapted to survive in extreme heat of the day, the cold of the night in the desert. Explain how each of the features mentioned below will give the camel a greater chance of survival in these conditions. So, pause the video, have a go at these 4 questions together, and then unpause the video and we'll go through them together. Right, should have unpaused the video. So, question 1. Hump with fat rather... that's not phrased very well, is it? Hump with fat rather than fat spread around the body. Now, if fat was spread around the body, it would trap heat. So, the reason why the fat is stored in the hump is it allows heat to escape the body more easily. Why does a camel have long eyelashes? We've mentioned this before. To stop sand getting into eyes. Why does it have wide-toed feet? So it can spread its mass across a larger surface area, and therefore on sand it can walk more easily. Leathery patches on the knees. Kind of obvious, really. So it can kneel on rough sand. Now, if you had a go at the question underneath, you might be able to answer this from stuff we've looked at in previous bits of this lesson. Suggest 2 reasons why Arctic foxes are covered in hair. Hair provides insulation. So, to stay warm in its current environment. And then, why is hair useful in snow? It also provides traction. So it stops it slipping when it's trying to scramble up piles of snow. So, 2 nice adaptations there. Right, moving on. Give yourself, please, a few minutes, pause the video, have a look at your previous lesson notes, and then we will go through the answers to these knowledge and application questions together. Right, should have unpaused the video, and now we'll go through these and just see if we can recall some of these key terms. So define a community. So it's two or more populations. So it's two more populations of different species living in one geographical area. Define extinction. Extinction is the loss of a species. Define abiotics. Abiotic are non-living factors. So species are organisms who can interbreed to produce fertile offspring themselves that can reproduce. 3 examples of structural adaptations. So structural adaptations are physical features. Sharp teeth. Camouflage, another physical feature. Large or small surface area to volume ratio. 2 functional adaptations. Photosynthesis in plants is a process. And production of poisons or venom for protection. Behavioural adaptations. Done a few of these. Courtship, dances, pack hunting. Another one might be less obvious. Shelter building, such as nests. Complete organisms adapted to live in extreme environments. What are they called? Extremophiles. Now a couple of recall questions from previous units of work. What is a protein? It's a biological molecule. And what is it made up of? It's made up of amino acid monomers. What is an isotope? So it's a version of an element. It's a version of an element which atoms contain a different number of neutrons. The elephant is well known for its large ears. A common misconception is that those ears are used to fan the elephant and keep it cool, when in fact the large surface area is designed to bring warm blood from the body closer to the environment, so the heat can escape and returning cooler blood back again. Suggest what type of adaptation this is. Big ears is a physical feature, isn't it? And if it is a physical feature, it is therefore a structural adaptation. Good, well done. Right, so just to finish off our thinking, if you turn back to your notes page, and I just want to go over a term we talked about at the very start of the lesson. Ecophysiology. So if you look at the bottom of your notes page, you might have a little bit more space if you want to make some notes. Now, as we said, ecophysiology is that term that was coined to show how features account for a species' ability to survive, its fertility, its abundance, its distribution. So a couple of examples I want to think about here in terms of what we've talked about. Ecophysiology for surviving in hot regions. So if you think, for example, about camels. Now, camels, they also have the features we've talked about in terms of fat distribution, reduced quantity of water being in urine. But another one is that they actually control the heat exchange in their nose, in their nasal cavity. So what happens is hot air mixes with moisture and it goes into the nose and it travels to the lungs and cools. Whereas exhaled air then is much cooler than that outside. So it condenses in the nose, and the cool, damp nose conditions allow for more inhalation and cooling down of air when it comes in through the nose. And this is important because it helps to reduce the amount of water lost in and out of the breath. Now, another less obvious adaptation is gazelles. As you can see in my amazing drawing of a gazelle here, is they actually chill the blood entering their head. So the blood in their body is warmer than the blood in their head. It's so that they don't overheat. Whereas a lot of organisms in and around kind of hot conditions don't do this, so they have the greater potential of overheating due to warm blood in their head. Whereas in colder regions, a lot of animals have adapted to have larger bodies and smaller extremities, such as ears, toes, feet, things like that, to reduce heat loss from these extremities because they have a smaller surface area to mass ratio. So slower heat loss, and there's a decreased exposure and decreased chance of these organisms, such as a nice little Arctic fox or polar bear, getting frostbite, whereas their extremities, the blood in their extremities, their toes, their paws freezes up and their paws drop off. So there's lesser chance of that. And then other examples. Musk oxen and polar bears, and also penguins, they have thick hairs on their feet to insulate them. And they're also warm-blooded in and around their feet, so it decreases the chance of blood freezing. Whereas if you put a lizard or an amphibian, lizard, reptile, something like that, into an Arctic environment, it'd freeze because it's got cold blood. Whereas a warm blood is more likely to survive in that Arctic environment. And then also, if you think about penguin, if you can see this amazing diagram, they have heat exchange mechanisms. So they have warm blood arriving from their body, which is then cooled to about 0 degrees by blood that's chilled from their feet, which is thus warmed up because it's colder. So it's this heat exchange mechanism that kind of keeps the blood at a rough temperature that's usable within the body. It warms up the cold blood, basically, that's been chilled by the feet and things being stuck in the snow, and those being the extremities of the organism. So just some examples of ecophysiology from what we talked about earlier. But in general, we've finished going through lesson 3, so you've got a comprehensive set of notes and hopefully some answers there, and hopefully you found today's lesson useful.